Hello everyone, welcome to my YouTube channel. Today we are going to solve a very interesting algebra problem in which we have to find the number of real roots of the given equation. So let's start. We are given e raised to the power 4x plus e raised to the power 3x minus 4 times e raised to the power 2x plus e raised to the power x plus 1 equals to 0. Now divide the given equation by e raised to the power 2x, we get e raised to the power 4x plus e raised to the power 3x minus 4 times e raised to the power 2x plus e raised to the power x plus 1 divided by e raised to the power 2x equals to 0 divided by e raised to the power 2x. On solving this, we get e raised to the power 2x plus e raised to the power x minus 4 plus e 1 over e raised to the power x plus 1 over e raised to the power 2x equals to 0. Now we can arrange this equation as e raised to the power 2x plus e raised to the power 1 over e raised to the power 2x minus 4 plus e raised to the power x plus 1 over e raised to the power x equals to 0. Now we can add or we can rewrite this equation as e raised to the power 2x plus 1 over e raised to the power 2x plus 2 times e raised to the power x times 1 over e raised to the power x bracket. Since if we solve this, e raised to the power x times 1 over e raised to the power x will cancel out and we get effectively 2. Since we have added 2 to this equation, we have to subtract 2 from this equation, and further on minus 4 plus e raised to the power x plus 1 over e raised to the power x equals to 0. Now if we look at this part, we can see this is e raised to the power x plus 1 over e raised to the power x bracket raised to the power 2, and remaining we have minus 2 minus 4 plus e raised to the power x plus 1 over e raised to the power 1 over e raised to the power x equals to 0, because we know a square plus b square plus 2ab is equal to a plus b raised to the power 2. So in solving this, we have e raised to the power x plus 1 over e raised to the power x bracket raised to the power 2 plus e raised to the power x plus 1 over e raised to the power x minus 6 equals to 0. Now assume or let e raised to the power x plus 1 over e raised to the power x equals to m. We get m square plus m minus 6 equals to 0. Now we can calculate the value of m by using quadratic formula, that is m equals to minus 1 plus minus under root 1 square minus 4 times 1 times minus 6 divided by 2 times 1. As we know, x is equal to minus b plus minus under root b square minus 4ac divided by 2a for any quadratic equation ax square plus bx plus c equals to 0. On solving the above question, we get m equals to minus 1 plus minus under root 25 divided by 2, and on solving this we get minus 1 plus minus 5 divided by 2. From here we get the two values of m, that is minus 3 and 2. Since we have two value of m, that is m equals to minus 3 and 2, also m equals to e raised to power x plus 1 over e raised to power x, which is a positive term, so m cannot be equal to a negative term, that is minus 3. So the value of m equals to 2. Now put the value of m, that is 2, and we know m equals to e raised to power x plus 1 over e raised to power x, which is equals to 2. Now bring this 2 on the left hand side, we get e raised to power x plus ex raised to power minus 1 minus 2 equals to 0. So we can write the above equation as e raised to power x bracket 2 times e raised to power x minus 1, and on solving this we get effectively e raised to power x plus ex bracket raised to power minus 1 minus 2 times e raised to power x times e raised to power x bracket minus 1 equals to 0. On solving this, or we can take e raised to power x minus 1 common from the above equation, we get e raised to power x bracket 2 plus 1 minus 2 times e raised to power x equals to 0. If you look at this term carefully, this is a square plus b square minus 2ab, which is equal to a minus b whole square. So the above equation can be written as a raised to power x minus 1 bracket e raised to power x minus 1 whole square equals to 0. We can write this as e raised to power x minus 1 bracket whole raised to power 2 divided by e raised to power x equals to 0. And when we cross multiply, we get e raised to power x minus 1 whole square equals to e raised to power x times 0, which is 0. So we get e raised to power x minus 1 raised to power whole as 2 equals to 0. The only way a power can be 0 when the base equals to 0, that is ex minus 1 equals to 0. So this can be written as e raised to power x equals to 1, and 1 can be written as e raised to power 0. Since the bases are same, their power will be equal. So x equals to 0. So the number of a real root of the given equation is 1. Thank you for watching this video. See you in the next.